Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in our easy manner. Now in our last class already I was explained very clearly how to identify the electrophile, how to identify the nucleophile, how the bond is breaking. Now if the bond is breaking, how the carbocation is forming, how the carbanion is forming, how the free radical is forming. Now clear? Now reactive intermediates already we have seen. Now whatever the reactive intermediates we have seen in the last class, for that reactive intermediates, now whatever the application we are going to study in this lecture, that is inductive effect, mesomeric effect and hyperconjugation. For that reactive intermediates we have to apply this, which one? Whatever the application we are going to study. So listen to the class very carefully. Now this application will play a very crucial role in our entire organic chemistry. Clear? Now let's start our lecture. Now how many types of the electron displacements that are happening in the which one? In the covalent bonds, because normally organic bonds has been formed by the covalent bond, right? Now types of electron displacements. Electron displacement means how the electron is moving from one carbon to another carbon, or one species to another species, either through the sigma bond, either through the pi bond, or either through the non-bonding. Clear? Now you see the types of electron displacement. Electron displacement in covalent bond. Clear? Now types of electron displacement in covalent bonds. Clear? First type of the electron displacement that we are going to study, inductive effect. Clear? Now second type of the effect we are going to study, that is mesomeric effect. This is a mesomeric effect. Clear? Now third type of the effect we are going to study, that is a hyperconjugation. Inductive effect, mesomeric effect and the hyperconjugation. This effect whatever we are going to study, that it will show every time, means it is a permanent effect. This is a permanent effect. Okay, this is a permanent effect. And the next other two types of the effects also we are having, that is electromeric effect. And the fifth one we are having the inductomeric effect. One is electromeric effect, another one is a inductomeric effect. These are the temporary effect. These are the temporary effects. Clear? Inductive, mesomeric, hyperconjugations are the permanent effects. Electromeric effect and the inductomeric effects are the which one? Temporary effect. Now first effect we are going to study, that is inductive effect. First one, inductive effect. See what is the meaning of the inductive effect? In the inductive effect, here what is the meaning of the inductive effect? Displacement of the covalent bond, right? Inductive effect, it will show if suppose carbon number 4, carbon number 3, carbon number 2 and the carbon number 1, and here it is a one halogen. It has been attached. One halogen it has been attached. Now halogen is a more electronegative than the which one? Carbon, right? When the halogen is a more electronegative than the carbon, what this halogen will do? Halogen, it will pull the bond pair of sigma bond pair of electron. These all are the sigma bonds, right? Sigma bond pair of electron towards itself, right? When this halogen is taking this sigma bond pair of electron towards this halogen will get which charge? Partial negative charge. This carbon will get which charge? Partial positive charge. Okay. Now whatever this C1 carbon has got the partial positive charge, to stabilize this carbon, to stabilize this C1 carbon, this C2 carbon, what it will do? It will help it will help. Or oh my C1 carbon, you are getting deficiency, I am there, I will help you. Okay, now this C2 carbon will help the, it's a sigma, this is also sigma bond, right? Now sigma bond pair of electron to the sigma bond pair of electron, whatever the deficiency this carbon is getting, that it was helped by the C2 carbon. Then C2 carbon will get deficiency. Done. Clear? C2 carbon will also get the deficiency. And when the C2 carbon has got the deficiency and C3 carbon, oh my dear friend, you are also getting deficiency, I am there, I will help you. Clear? Now this C3 carbon will be giving its electrons to the C2 carbon where it is getting its electron deficiency. Clear? In this manner, electron deficiency, partial positive charge on the carbons it is getting. When this halogen has been attached to this carbon is a less electronegative, halogen is a more electronegative, it will take the bond pair of electron towards itself in the form of which bond? Sigma bond, right? To the sigma bond. Electrons are displacing through which bond? Sigma bond. That's the reason here this inductive effect is nothing but, now this C4 carbon inductive effect will be almost negligible. Almost up to C3 carbons only the inductive effect will be present. C4 carbon inductive effect will be negligible. Clear? Now what is the proper definition of the inductive effect? Displacement. What is the meaning of displacement? These electrons are displacing through the sigma bond. Displacement of sigma electrons or sigma bond pair of electrons in covalent bond. This will form the covalent bond only, right? In covalent bond towards more electronegative atom is called inductive effect. This is a definition of the inductive effect. Clear? Now this effect, this is a permanent effect. Clear? Now next very key point you have to remember, it is a distance dependent. It is distance dependent. It is which one? It is a distance dependent. Means up to third carbon inductive effect is present. Clear? From fourth carbon IE inductive effect is negligible. Done? Inductive effect is negligible. Clear? Now here, based on the which one? Polarities. Here we are getting the polarities, right? You can see here this is a partial negative charge and this is a partial positive charge. Depending upon these polarities, now inductive effect has been divided into two types. One is electron loving and one is electron repelling. One is electron loving and one is a electron repelling. Means inductive effect has been divided into two types. This inductive effect has been divided into two types. One is plus I groups. What is the meaning of the plus I groups? Plus I groups means electron releasing groups are electron repelling groups. Clear? Done? Now next type of the groups we are having minus I groups. Minus I groups means electron withdrawing towards itself. Electron withdrawing groups are electron attracting groups. Electron attracting groups. Minus I groups are the electron attracting group and plus I groups are the electron repelling groups. Now what are the plus I groups and what are the minus I groups? Now we'll see. Okay, first these are the very important. You have to remember this order which I was going to give. If you remember this order, according to this order, if you remember, whatever may be the questions they may ask on the basis of inductive effect, you will never and ever you will do the mistake. Done. First, plus I groups order. First one is a O negative. Clear? Done. Next, PHO, phenyl oxide. Clear? Next, C double bond O, O minus. Clear? Next, 3 degree. Now 3 degree carbon. Next, 2 degree carbon. Next is a 2 degree carbon. Clear? Next is a 1 degree carbon. Done. Next will be the ethyl or methyl. Clear? Next, tritium. Next, deuterium. Next is a hydrogen, etc. Now this is a plus I order, plus I effect order. You have to remember. Same order, you just remember. Now comes to the minus I effect order. Minus I effect order. Which groups will withdraw the electrons, or which groups will be withdraw the electrons, or which groups will be attract the electrons? Those groups which we have studied about the plus I, those will repel. Now these groups will be, what it will do? It will withdraw. Okay, the first minus I group order, first one is a O positive. More electronegative atom bearing the positive charge is unstable, so this will withdraw the electrons very fastly. O minus. Done. Next one will be the NF3 plus. NF3 plus. Next one will be the NH3 plus. NH3 plus. Done. Next one will be the NO2. Next one will be the cyanide. Clear? Then after that, sulfonic acid. Clear? Next one will be the aldehyde. Clear? Next one will be the ketone. Done. Next one will be the carboxylic acid. Done. Next one will be the ester. Clear? Next one will be the acid halide. Clear? Next one will be the acid amide. Clear? Next one will be the fluorine. Next one will be the chlorine. Clear? Next one will be the bromine. Next one will be the alcohol, OH. Next one will be the amine, etc. Clear? Now this is a which one? Minus I effect order. This is a minus I effect order. If you want, you will get the triple bond also. You will get triple bond greater than double bond. Triple bond greater than double bond. Clear? Done. Now here, after we have seen the plus I groups which are the electron repelling or electron withdrawing. Now next we have seen the minus I groups which are electron donating, which are electron withdrawing, or electron loving. Clear? Now based on this one, now we have to apply the which one? Inductive effect. Application of inductive effect. Application of inductive effect. Application of inductive effect. Where we can apply this inductive effect? Where we can apply this inductive effect? First, we can apply this inductive effect in the seeing the stability of carbocation. By applying this inductive effect, application of this inductive effect, we are applying to the carbocation. See that plus I groups we have seen, minus I groups we have seen. If that plus I groups are attached to the carbocation, what happened to the carbocation? Now if the minus I groups are attached to the carbocation, what happened to the carbocation? Whether it will feel stable or whether it will feel unstable, that we are going to see. First one. Second one, stability of carbanion. Second, we have seen stability of carbanion. Now, third, stability of free radicals. Okay, stability of free radicals. Done. Next, fourth. Next, stability of which one? Acidic nature. Stability of acidic nature of alcohol and carboxylic acid Clear? Fifth one, we are going to see stability of amines. Stability of amines or basic nature of amine. This is, we can take it as a basic nature of amines. Done. And the next, sixth one, we are going to see which one? Dipole moment. And seventh one, we are going to see the bond length. Clear? Now, this many in this inductive effect we are going to apply in the how many? Carbocation, in the carbanion, next free radical, next acidic nature of alcohols and the acidic nature of carboxylic acid and the amines in the dipole moment and the bond length we are going to see. Now the first one we are going to see the stability of carbocation. Now stability of the carbocation, how the inductive effect will be applicable, now we'll see. We know carbocation, this is a carbocation. Carbocation is a electron deficient, right? Carbocation is which one? Electron deficient. If the carbocation is a electron deficient, now carbocation will take the electron or carbocation will give the electron? Now this carbocation will take the electrons. Means if the carbocation will take the electrons, means which groups will be stabilize the carbocation? Electrons repelling one or electron attracting one, or plus I groups will stabilize the carbocation or minus I groups will be stabilize the carbocation. Clear? Plus I groups will be electron release, right? So electron release means, can I say plus I groups increases the stability of carbocation. The word stability means it reaching to lower energy. It leading to the lower energy. Clear? Now every atom, molecule or compound want to try to attain the which one? Stability, to reach or to acquire the lower energy. Clear? Now every compound want to attain the stability to acquire the lower energy. Clear? First point, this is a very key point you have to remember. Plus I groups increase the stability of carbocation and minus I groups decreases the stability of carbocation. If you remember these 2 points, now many of the questions whatever they are asking, now that you can solve very easily. Done. Clear? Plus I groups, whatever the plus I groups already I explained very clearly. Done. Now first we'll move to the clear. Now here the one carbon CH3. Now here this carbon and here it is a carbon CH3. Now here it is a positive charge and here it is a carbon. Clear? And the next we are having the CH3. Now here the CH. Now it is a positive charge and here it is a CH3. Clear? This is a 1. Now this is a 2 and this is a 3. CH3 CH2 plus. Clear? Now this is a normal CH3 plus. Okay, this is a 4. Now among these 4, which is the more stable carbocation, they will ask you. Now you see here we are having the 1 plus I groups. Now here is also 1 plus I group. Now here is also 1 plus I group. Clear? Now here the 3 plus I groups are attached to the 1 carbocation, right? Clear? More the plus I groups, more will be the stable. More the plus I groups, more will be the stable. Among these four, this first carbocation will be stabilized very fastly due to the 3 plus I groups. Now next, here we are having only 2 plus I groups. Here only 1. Here there is no any carbocation or methyl groups to stabilize that one. The order will be order of or stability order of carbocation. Stability order of the carbocation will be 1 greater than, 2 greater than, 3 greater than 4. 1 greater than, 2 greater than, 3 greater than 4. Clear? Now this is the order. Clear? Now next one. If suppose if they have given tritium CH3 CH2 plus. Done? Clear? Next we are having the deuterium. Clear? And it is having the plus. Now next we are having the methyl. Clear? Now among this 1, 2 and 3, among this 1, 2 and 3, which one will be stabilize the carbocation very fastly? Now listen. Here this one, carbon and the tritium. Now what bond length is small. Clear? Now next, carbon and the deuterium. Now this is a carbon and the hydrogen. Now you see this carbon and the tritium, sigma bond is somewhat smaller size, right? Now due to the smaller size, now tritium can donate the electron pair to this carbon very fastly. Next, deuterium. Next, now hydrogen, this carbon and the hydrogen bond length is high, right? So in comparison with the tritium, carbon and hydrogen, or hydrogen donating its sigma bond pair of electron towards the carbon is less in comparison to the tritium. So which one will be stabilize this carbocation very fastly? First tritium, next deuterium, and the next will be the CH3, right? Now the order will be 1 greater than, 2 greater than 3. Next example. Now next model of the example for the application of the carbocation with the inductive effect. Now you see CH3 CH2 plus. Okay, next CH2 double bond CH plus. This is a first one, this is a second one. Now third one will be the, here we'll take third one will be the CH triple bond C plus. Okay, now here what is the reason of this? Which is a more stable carbocation? Means 1 greater than, 2 greater than 3. Why 1 greater than, 2 greater than 3? Because you can see here this carbon hybridization, or whatever the group attached here for this carbon, here this one has been formed by the which overlapping, this was formed by the bond with the sp3. Clear? Now this carbocation has been formed by the which one? sp2, and this carbon is sp2 carbon. Now here this carbon is a sp carbon. Clear? Now this carbocation is present in the sp, this carbocation is present in the sp2, and this carbocation is present in the sp3. And we know right, as the percentage s character increases, electronegativity increases. Now carbocation stability decreases. Clear? Now we know percentage s character in sp is 50. Now percentage s character in sp2 is 33.3. now percentage s character in sp3, that is 25%. Clear? Now as the percentage s character increases, electronegativity increases, carbocation stability decreases. Now you see this one, sir, how it has formed? If you are getting confusion, now you see this is CH3, this is CH3. Clear? By this carbon is the sp3 right before. Now by this the loss of this one hydrogen only, this carbocation has been formed. Whatever the carbocation it has formed, that is due to the sp3. Before here it is a sp2, before it is a sp. Clear? Now in the percentage s character in the sp is high. If the percentage s character is high, electronegativity is high. So more electronegative atom bearing the positive charge is unstable. Here is also sp. Now here it is sp2, here it is a sp3. Clear? That's the reason. Now stability of the carbocation will be 1 greater than, 2 greater than 3. 1 greater than, 2 greater than 3. Clear? Now next, one carbocation and here it is a fluorine is attached. Okay, next, now here the next one NO2 is attached. Clear? Next one will be the, here the cyanide is attached. Now here we may think that NO2, CN and the fluorine. minus I group order. Minus I group order, first NO2 will be the higher, next CN, next will be the fluorine. This is the actual minus I order. Then we may think that here carbocation, now minus I group, minus I groups will be destabilize the carbocation, and these are the which NO2 is a strong minus I, next CN, and next will be the fluorine. So the order we may think, and it will be in your option also, first 1 is a more stable carbocation, next to 2 and 3 we will think, no, now we will think first is a more stable carbocation, next will be the 3 and the last will be the 2, but actually this is wrong. Why? Because already I explained you, what I explained you, inductive effect. Inductive effect is a distance dependent, is a distance dependent. Here this carbocation, now whatever the group it is nearer to that one, if the plus I group if it is there, that it will be stabilized very fastly. If any minus I group if it is there, it will destabilize that carbocation very fastly irrespective of the order. Now you see here the NO2 is somewhat far away from the carbocation. Now the cyanide is somewhat more far away from the carbocation. See, now this cyanide is almost far from the 3 degree or 3 carbons, right? So first more stable carbon is the 3. Then next compared to this one, this carbon is in the this position 1, 2, 3, 4, let's take. Now carbocation is present in C1. Now minus I group is present in C3, somewhat far away from the distance, right? So it is 2. Clear? Now here it is present with the C2 carbon, it will destabilize this carbocation very fastly and the order will be 3, 2, 1. 3, 2, 1. Clear? Inductive effect is a distance dependent. Blindly believe this one. Okay? Now next example. Next example, if you go, now here it is a one positive charge. Okay? Now next, here is a one positive charge and here it is a fluorine. Then next, here it is a one positive charge and here it is a fluorine. Now here is a one positive charge and here it is a fluorine. Clear? Now what is a carbocation stability order, they will ask. Carbocation stability order they will ask. Now what is the carbocation stability order? Now you can see this is a positive charge and this is a CH3. CH3 is a plus I group, right? Plus I groups will stabilize this carbocation very fastly. So the one is more stable. Done. Now comes to the second one. This is a fluorine is a minus I group and minus I group. Clear? Minus I group is nearer to the carbon, right? It will destabilize the carbocation very fastly. So the 2 will be last. Among the 3 and 4, now check the distance. Already I explained you. Inductive effect is a distance dependent. This is 4 is, in the fourth one, fluorine is far away from the carbocation, right? This is C2, this is C3, this is C4. Now it is present in C3, it is present in C2. Clear? Now the 4, 3 and 2. Now this is a order. This is a order. Clear? Next. Next very important we are going to study. Now by seeing the pictures itself, I think so you got some idea or not, I don't know, but now I will explain very clearly. Listen. Now here whatever the pictures you are seeing, these pictures are for the bicyclo compounds. Now already we have studied about the bicyclo compounds. This is a fused compounds or bicyclo compounds. Now this is a bicyclo compounds, right? Now this is a bicyclo compounds. In this bicyclo compounds, these are the bridged carbons. These are the bridged carbons. Done? Now you see, in this bicyclo compound, here this is a bridged carbon. Now this is a bridged carbon. This is a bridged carbon. This is a bridged carbon. Now this one, you can see. Now this one is a bridged hydrogen. This is a bridged hydrogen. This is a bridged hydrogen. Here the one hydrogen will be there, right? Here the one hydrogen. These are the bridged hydrogens. Clear? Now whatever the sigma bond it is having, this bridged hydrogen p orbital will be in this manner. This bridged hydrogen p orbital will be in this manner. Okay? Now here this adjacent carbon p orbital will be in this manner. Means you can see this bridged carbon p orbital and adjacent carbon p orbital is perpendicular to each other or parallel to each other? Those are perpendicular to each other, not parallel to each other. Remember, clear? These two p orbitals are bridgehead carbon p orbital and adjacent carbon p orbitals are perpendicular. Okay, this is forming the sigma bond only. But if I remove this hydrogen, now the positive charge will be here, right? The positive charge will be here in this p orbital. Now, due to that one, what happens? Whatever the positive charge it has present on the bridged carbon, for this bridged carbon, now this sigma bond is not having a chance to stabilize. It is losing its planarity. So, which one? Adjacent carbon p orbital electrons will not stabilize this bridged carbon empty orbital or carbocation. So by this one, what you have to remember, this is a very, very important point. So in a bicyclo compounds, bridged carbon bearing positive charge is unstable. This is the very, very key point you have to remember. So bridged carbon bearing the positive charge is unstable because adjacent p orbital is not having a chance to stabilize, because due to that it lost its planarity. Clear? It is which lost its planarity, with adjacent carbon p orbital. Clear? That adjacent carbon p orbital will not stabilize the which one? Both are perpendicular. This bridged carbon, if it is having this positive charge, means now this adjacent carbon p orbital will be in this manner. See, both are at the 90 degrees. Clear? Due to that it will not be stabilized. Clear? Now, bridged carbon bearing the positive charge is unstable. Blindly believe. Now we'll do some questions based on this one. If suppose here the one positive charge they have given. This is 1. Now second compound they have given. Now here it is a positive charge they have given. Clear? Now among the 1 and 2, which is a more stable carbocation, they will ask. Now why? Bridged carbon bearing the positive charge is unstable, we know, right? This is unstable. Clear? This is unstable. Next one, if suppose any cyclo ring they have given. Cyclo ring if they have given, then if they ask the stability order, first one, this is a cyclopropane. Now this is a cyclobutane. Now next one, this is a cyclopentane. Now this one is a cyclohexane. Now among the 1, 2, 3, 4, which is a more stable carbocation if they ask? Now 4 is a more stable, next to 3, next to 2 and the next to 1. Reason, what is the reason for it? Means here in the cyclopropane, bond angle strain is almost 49 degrees or 49 degrees will be there, bond angle strain. Clear? Next, in the cyclobutane, bond angle strain is almost equal to the 20 degrees will be there. Done. Next, in the which one? Here this one is a cyclopentane. Approx it will be the equal to 1 degree. Now in the cyclohexane it will be the 0 degree. Clear? Lesser the bond angle strain, more will be the stable carbocation. Lesser bond angle strain, more is the stability of carbocation. More is the stability of carbocation. Is it clear? Done? Clear? Lesser the bond angle strain, more will be the stability of carbocation. Now, next we'll move to the second, we'll move to the stability of carbanion. For the carbanion, how the stability of carbanion. Now, in the stability of the carbanion, now you see, this is a carbanion, right? This is a carbanion. For the carbanion, now for the carbon, it is having the 8 electrons, right? 8 electrons it is having, means its octet is completed. Octet completed. If the octet completed means, clear? Now why the again it will take the electrons? Why it will take the electrons? Now here it is feeling some excess of electron, right? Because this negative charge is charged species. Every compound want to become the which one? Neutral species, not the charged species. Means this carbanion is ready to give the electron, but not readily to take the electrons. So for this carbanion, which groups will be stabilize the carbanion and which groups will be destabilize the carbanion? Now we know, right? Plus I groups will release the electrons. If the carbanion take the electron, still it will become destabilized. So plus I groups decreases stability of carbanion. Now minus I groups increases the stability of carbanion. Okay, remember this point. Plus I groups decreases the stability of carbanion, minus I groups increases the stability of carbanion. Now you see, first one, if suppose here this is a one carbanion, here the 3 methyl groups are attached. Done. Next, here the one CH3, here one carbanion, here the CH3. Done. Clear? Now next one will be the CH3, CH2 anion. Now among the 1, 2 and 3, which is a more stable carbanion, they will ask. Which is a more stable carbanion? 1, 3 greater than, 2 greater than 1. Why? Because here these are the, all are the plus I groups, right? These are the, which one? Plus I groups. Plus I groups will be destabilize the carbanion. Clear? More the plus I groups, more will be the destabilization of the carbanion, because more the electrons if it is give, more it will become deficiency. Already it is having some charged species. Clear? By taking the, it is want to give the electron to become neutral. Clear? But still if you readily give the electron, what happened? The charge will be increased and it will become destabilized. It will become destabilized. Clear? Next person. Next, if suppose CH2 negative, if here the fluorine is attached. Okay, this is one. Now second, CH2 minus, and here the NO2 is attached. And third, CH2 minus, and here it is a CN is attached. Okay, now third one, fourth one, CH2, now CH2 minus, and here it is a which one? One CH3 is added, let us see. Okay, now which is a more stable carbanion? Now we have to see. Here this all the 4 cases distance is same. CH2 minus, CH2 and minus I groups are there. Now minus I group order, first one NO2 is a strong electron withdrawing group, right? Now this carbanion also will be ready to give the electrons. So the one which readily take the electrons will stabilize this carbanion very fastly. So the order will be 2 greater than, 3 greater than, 1 greater than 4. Why? Because this is a plus I. Now minus I order we know, right? NO2 greater than CN, then after that fluorine. Now this is the order. Clear? Next, if suppose CT3 minus, CH2 negative. Okay, this is the one. Now second, CD3 minus, CH2 minus. Clear? Now CH3 minus, CH2. Now among this 1 to 3, which is a more stable carbanion? Which is a more stable carbanion? Now, which is a more stable carbanion? 3 greater than, 2 greater than 1. 3 greater than, 2 greater than 1. Why? See, this tritium, carbon and the tritium bond length is less, and the carbon and the deuterium bond length is somewhat high. Now, carbon and the hydrogen bond length is somewhat more. Clear? Now, this tritium is readily giving the electrons. Now, next compared to the tritium, next deuterium, and the hydrogen is giving the electrons very lessly to the carbon, right? Means due to the distance dependent, 3 greater than, 2 greater than 1. So, the one which give the electrons very less or very slowly will stabilize the carbanion very fastly. Will stabilize the carbanion very fastly. Clear? Now, next. If the CF3 minus, this I will explain when mesomeric effects start. Okay. Now, with the another example, CF3, now CH2 minus, this is a 1. Now, second one, CHF2 or CF2, here the H and here the CH2 minus. Now, third one, now CF, here the H, here the H, now here is a CH2 minus. Clear? Among the 1, 2, 3, 4, among the 1, 2, 3, which is a more stable carbanion? Now 1 is more stable carbanion, next to 2, next 3. Because here the 3 minus I groups are there, here only 2, here only the 1. More the minus I groups, more will be the stable, Clear? Next. Here the negative and here it is a Cl first. Now second one, now here it is a Cn, now here it is a negative. Now third one, clear, it is a NO2 and here it is a negative. Which is a more stable carbanion? Now the more stable carbanion will be the 1 greater than, 2 greater than 3, irrespective of the minus I effect, because inductive effect is a which one? Distance dependent. Clear? The one which is more nearer will be the more stable for the carbanion, minus I group. For the carbocation, the one which far away from the carbon or carbon deficient carbon is more stable carbocation. Clear? Now this will be the 1, 2, 3. Here for this carbanion, this minus I group is nearer, somewhat far. It is more far. Clear? Done. Next. Third one. Most of the cases, the stability of the carbocation we will explain on the basis of hyperconjugation, but with the inductive effect also. But stability of the free radical and the stability of the carbocation will be almost the same, because that is electron deficient. Free radical is also electron deficient. Done. Stability of the free radicals. In the stability of the free radicals, we know carbon radical is a, how many electrons carbon radical is having? 7 electrons. So octet incomplete. Done. And octet is 7 electrons and octet incomplete. Next, this is which one? Electron deficient or electron sufficient? This is electron deficient. This is a electron deficient, right? This is a electron deficient. Means which groups will be stabilize the free radicals? Plus I groups increases the stability of carbon radical, and minus I groups decreases the stability of carbon radical. Clear? Now this is a very key point you have to remember. So clear? Now you see here the CH3, here the C, CH3, and here it is a CH3, and here it is a radical. 3 degree radical is greater than 2 degree radical greater than 1 degree radical. Clear? Why? Because 3 degree radical, here we are having the 3 plus I groups. 3 plus I groups we are having. 3 plus I groups we are having. 3 plus I groups more stable radical, because these 3 groups are ready to give the electron for that free radical to make the stability. Clear? Now next fourth one, we are going to see the acidic nature of phenol, or sorry, acidic nature of alcohols. Acidic nature of the alcohols. How the acidic nature of the alcohols will be explained on the basis of the inductive effect. Now we see. Now first of all, before going to the study of the acidic nature of the alcohols, now before going to this one, try to study the what are the acids we are having. First we are having the areneous acid, right? We are having the areneous acid. What is the meaning of the areneous acid? This areneous acid is nothing but compound which, okay, if you are getting confused, this one is which means, now this is which gives, compound which gives hydronium ions in water is called areneous acid. Okay, that is areneous acid. Next, second one is a areneous base. Now what is the meaning of the areneous base? Compound which gives OH minus ions in water is called areneous base. Clear? Now which gives a hydronium ion is known as acid, which gives a OH minus is a base. Clear? Next type of the acid already we have studied, Lewis acids. Lewis acids. What is the meaning of the Lewis acid? Electron pair acceptor. Electron pair acceptor. Electron pair acceptors are Lewis acid. Clear? Electron pair acceptors are the Lewis acids. Done? Or example, electrophiles. Electrophiles. Clear? Electrophiles are the example for the which one? Lewis acids. Next one, Lewis bases. Lewis bases. What are the Lewis bases? Electron pair donors. Electron pair or electron pair donors. Examples are the nucleophiles, right? Nucleophiles. Done? Clear? Areneous acids means what, and the Lewis acids and the Lewis bases means what, we have studied very carefully. Clear? Now here next type of the acid we are going to study, that is Bronsted acid and the Bronsted base. That is Bronsted acid. What is the meaning of the Bronsted acid? Means proton donor, H plus donor. H plus donor is a Bronsted acid. Now Bronsted base. Bronsted base means what is the meaning of the Bronsted base? H plus acceptor. H plus acceptor. Done? Clear? H plus acceptor is known as a what? Bronsted base. H plus donor is a Bronsted acid. See, based on these two key points only, we are going to decide the acidic nature of the alcohols or carboxylic acids. Clear? Bronsted acid and the Bronsted base stability only, we are going to identify which is a strong acid, which is a strong base. Clear? For what is the meaning of the Bronsted acid, I will explain. Listen carefully. So first, if I clear the What is the meaning of the Bronsted acid and what is the meaning of the Bronsted base? Now whatever may be the question they may ask on the acids, now your doubt it will be clear for you. So first best example for you, first I was taking the, what I was taking? When I was taking the HCl, okay, HCl I was taking, HCl plus H2, HCl plus H2O gives rise to hydronium ion plus Cl minus. This is a Cl minus. Clear? Now this is an equilibrium reaction. Here which is the acid and which is a base? One which is H plus donor. Here this H plus, HCl, H plus and Cl minus, it will be dissociate. Now this H plus was being accepted by this H2O, right? Means here the H2O is a which one? Base. H2O is a base. So this HCl, it has donated its H plus, right? This is a acid. This is a acid. Done? Now when this base has accepted this one, which one? Positive charge, and it has been converted into which one? Conjugate base. These terms will play very important role in the identification of the alcohol and the acidic nature of the alcohols or phenols or whatever may be, alcohols or phenols or carboxylic acids. Here this is a conjugate acid. Now for this acid, this one is a conjugate base. This is a conjugate base. Clear? Now stability of this conjugate acid and stability of this conjugate base only we will say whether the given compound is a strong acid or strong base. Strong acid or the strong base. Clear? Now what? Depending upon the, if the conjugate base and this is a conjugate acid. Clear? Now acidic nature. Clear? Acidic nature, how to decide? This conjugate base acids, acidic nature, if they ask acidic nature means this acid is giving in the compound what? Conjugate base, right? Acidic nature is decided on the basis of how? Acidic nature is decided on the basis of stability of its conjugate base. Stability of its conjugate base. Stability of its which one? Conjugate base. Conjugate base is positive charge or negative charge? Acids conjugate base is negative charge. Then this conjugate base is negative charge means it is if it suppose bearing the negative charge means it is feeling some more electron density. More electron density will be stabilized by the plus I groups or minus I groups. Already we have seen about the carbanion case. In the carbanion case, minus I groups will be stabilize the carbanion and plus I groups will be destabilize the carbanion. In the same way, minus I groups increases the stability of conjugate base, plus I groups decreases the stability of conjugate base. Sir, I was not understand, sir. Can you explain more elaborately? Now listen. Now what is the how the minus I groups increases the stability of the conjugate base, how the plus I groups decreases the stability of the conjugate base? Now with the example I will explain very clearly. Now you listen. Yeah? Now here let's suppose one CH3 OH I was taking. Done? No. Here one CH2 OH, one CH2, or I was taking here the one fluorine, and here it is I was taking the OH. Okay. Now here I was taking the one CH2 OH, and here I was taking the NO2, let us assume. Okay. These are the 1, 2, 3 compounds I was taken. These all are the acids. Okay, these all are the acids. Now for these acids, what? For these acids, how the acid, which one is a strong acid to say, for that one what you have to do, whatever may be the compound they may give, first key point you have to see acid. If they ask, just this is a acid, right? This is a one methanol. One thing you do, first if they ask, actually the question they will give you in this manner only, then to predict that given question very fastly, what you do, just you remove this hydrogen from the oxygen. This, consider that this hydrogen has been given to the solution. If this hydrogen has been given to the solution means, or if this hydrogen has been given to the solution means, this oxygen is a more electronegative, right? It will take the bond pair of electron. When it has taken this bond pair of electron, now it will become CH3O minus. Done. Then here also, now write its a conjugate base, CH2FO minus. Now this is CH2NO2O minus. Now you see, for these acids, these all are the conjugate bases, right? These all are the conjugate bases. These all are the conjugate bases. These are the conjugate bases. Clear? Now here also you can see, this is acid HCl. HCl, after the loss of its hydrogen, now it has become the conjugate base. Now this conjugate base, if it is stabilized very fastly in the solution, that is strong acid. If this what conjugate base, if it is not stabilized very fastly in the solution, that is least basic, least acidic. What? If this conjugate base, if it is stabilized very fastly, that is strong acid. If this conjugate base is less stabilized, that is least acidic or least acid. Done. Now listen carefully here. You see, here for this oxygen, already negative charge it is there. Here the group attached is the plus side. Here the group attached is a which one? Plus side. This plus side group, what it will do? It will give the electrons to the oxygen. When still it is giving the electrons to the oxygen, means oxygen still the electronegativity or electro density on the oxygen will be increased. When the electron density on the oxygen increase, that it will feel unstable. When it is feeling the unstable, whatever the hydrogen it has given to the solution, that it will be, what it will be? It will taken back. It will be taken back and it will become the neutral again. It will become neutral again. One which donate the hydrogen to the solution very fastly, and its conjugate base, if it has become stable, that is a strong acid. Okay na? Clear? Now you see, this due to the presence of this plus side, its conjugate base stability is decreasing. Now comes here. Now this oxygen, it is bearing the negative charge, but here the minus I group is attached. Minus I group is attached. Minus I groups will be stabilize this carbanion somewhat effectively than the first. But compared to the fluorine, this NO2 is having the more minus I effect. So compared to the fluorine, this NO2 will stabilize this conjugate base very fastly, right? So what is the acidic nature order? 3 greater than 2 greater than 1. That's it. Simple. Clear? 3 greater than 2 greater than 1. Whatever may be the alcohols they may give, remove the hydrogen and put the what? Negative charge on the oxygen and see the stability of that negative charge. Minus I groups will be stabilized and plus I groups will be destabilized. That's it. Simple. This you remember. Now it is enough. If you remember this one, it is enough. Clear? And next. Sometimes they will ask you, they will give you the what? They will give you the 2 or 3 compounds and they will ask you among this one which is having the higher pKa. Which is having the higher pKa or Ka. What is the pKa and what is the Ka? Means if you take the acid Ha acid plus H2O. This is the acid in the presence of H2O. Blindly believe that organic acids, carbon containing acids are weak acids. Carbon containing acids are weak acids, because that's the reason only equilibrium will be exist in the which one? H2O. Weak acids are partially dissociate, right? So Ha plus H2O in the presence of H2O, it will give one conjugate base and one will be the here BO plus H3O plus, right? This is a H3O plus. Clear? Now, if I write the dissociation constant, acid dissociation constant, this is what? Dissociation constant for an acid. This is a dissociation constant for an acid, right? Now, how to write the dissociation constant for an acid? Clear? This one will be the, which one? Products by reactants, right? Now, activity coefficient for the pure liquid will be taken as a 1. Clear? Activity coefficient for the pure liquid will be taken as a 1. Means here one key point you have to remember, Ka is directly proportional to the acidity. Ka is directly proportional to the acidity. Then pKa is inversely proportional to the acidity. pKa is inversely proportional to the acidity. Clear? Now, Ka is directly proportional to the acidity and pKa is inversely proportional to the acidity. Clear? This point, if you remember, now whatever may be the pKa and the Ka quotients they have given, you will never and ever make the mistake. Clear? Now, factors affecting the acidic nature of compounds or acidic nature of the compounds. Now we'll see. First, what are the factors that are affecting? Factors explain the acidic nature of compounds. What are the factors that will explain the acidic nature of the compounds? Then first one will be explained on the basis of electronegativity of elements. Second, bond energy or bond strength. Third, stability of conjugate base. This stability of the conjugate base, it explains on the basis of inductive and mesomeric effect. Clear? First and fourth one will be the solvent. On the basis of the solvent also we can say the which is a more acidic and which is a less acidic. Okay. First one will deal with the electronegativity of element. Which one, on the basis of the electronegativity, how we can decide the which is more strong acid. Clear? First one, in periodic table, this is a PT means periodic table. If you move from the left to right in the periodic table, what? Acidic nature increases. Clear? How the acidic nature increases? Now you see. Here CH4 it is given. Done. NH3 they have given. H2O they have given. And HF they have given. Now what I said, acidic nature means hydrogen should be given to the solution very fastly and it's a conjugate base. If the hydrogen is given to the solution for this CH4 and its conjugate base will be the CH3 minus. Done. Now here this is NH2 minus. Now here it will be the OH minus and here it will be the F minus. Clear? You see, electronegativity is increasing, right? Means electronegative atom bearing negative charge is more stable. Is more stable. Clear? That's the reason. That's the reason HF is a now acidic nature order. Acidic nature order. Where in the left to right periodic table on the basis of electronegativity. On the basis of electronegativity in periods. This is in period. So when it comes to the groups, it will be somewhat different in groups. In the groups, HF, first one, second one, HCl, now third one, HBr, and the fourth one, HI. Okay. Now here you can see, here hydrogen and the fluorine is having the bond length is small. Bond length is small means here to break this bond, let's suppose I was giving the 50 kilojoules of energy. Let us assume when I was giving the 50 kilojoules of energy, this HF is not breaking. This hydrogen and fluorine bond is not breaking. Means if the hydrogen is not giving to the solution, means why we can say this as a strong acid? No. At the 50 kilojoules of energy, this HCl is also not giving the hydrogen to the solution. So this is also not right. For the 50 kilojoules of energy, HBr is also not giving. But for the 50 kilojoules of energy, now what? HI is giving the hydrogen very fastly because the bond distance between these two is high. When the bond distance between these two is high means easily it will be broken out. When easily it is giving the easily if it is giving the H plus to the solution means this HI will be more stable. This HI will be more stable means that's the reason HI is more acidic. HI is more acidic. Then next, if I give the 60, for these two are not giving the HF is not giving the H plus to the solution. HCl is also not giving, but HBr is giving. Then at the lesser energy, what? One which gives the hydrogen to the solution very fastly is the strong acid, or else you can say on the basis of this one. Now the one which is having the lesser or one which is having the higher bond length will give the hydrogen to the solution very fastly. Here it is having the stronger bond strength. It will not give the hydrogen to the solution very fastly. That's the reason HF is a weak acid in the groups. Not the period, in the groups. So HI is stronger acid. Next HBr. Next is the HCl. Next is a HF. This is a order. Clear? Next, based on this one, if suppose CH3 they have given, ethane they have given. Then second one they have given which one? Ethene they have given. Then third one they have given ethyne they have given. Now among the 1, 2, 3, which is a stronger acid they will ask. Now you see, already I explained very clearly. Percentage S character increases, electronegativity increases. Now electronegativity increases means acidic nature increases. Why? Its conjugate base stability increases. Sir, how the conjugate base stability increases, sir? Now listen. Here this is CH3. This is CH3. Now if the hydrogen is given, its conjugate base will be CH3 CH2 minus. This is a conjugate base of the which one? Ethane. Now ethene conjugate base will be the CH3 CH2 double bond. Now ethyne conjugate base will be the CH triple bond C negative. Now you see, this carbon hybridization is a sp3, this carbon hybridization is a sp2, this is sp. Now sp percentage S character will be more, then sp2, then sp3. So 3 greater than 2 greater than 1. That's it. On the basis of electronegativity, we have said the which one? Acidic nature. Clear? Done. Now we'll see some general example with the electronegativity also. If suppose first one NH3 and PH3 they have given. which is a more strong acid if they ask. Already I said top to bottom, if you move, top to bottom if you move, now acidic nature increases, left to right if you move, acidic nature increases. Top to bottom if you move, which one increases? Acidic nature increases. See first NH3, then it will come the pH3, right? So pH3 is a more acidic, more acidic. Second one, if H2O and H2S if they ask, H2S is a strong acid because top to bottom acidic nature increases. Then third, HF and H2O if they ask, which is a strong acid? HF is a strong acid. Left to right, right? This is left to right in the PT because first oxygen will come, then after fluorine. Here first nitrogen will come, then after phosphorus. Here first oxygen will come, then after sulfur. Done. This is left to right, this is top to bottom, top to bottom. Done. Next. No, next. Next, second, on the basis of bond strength, right? On the basis of bond strength also we can explain the acidic nature. On the basis of bond strength also we can explain the acidic nature. How we can explain on the basis of acidic on the basis of bond strength? Now you see here CH3 CH2 or CH3 CH2 OH. Okay. Now CH3 CH2 OD. Clear? Now already I explained you carbon and the oxygen and the hydrogen bond length is high. Bond length is high. Here the OD and the bond length is somewhat small compared to the OH. Means here the bond strength, oxygen and the deuterium bond strength is high. Here the bond strength is weak. If the bond strength is weak means this hydrogen will be given very fastly. Here the OD it will not give. So this is a stronger acid than the OD. This is a stronger acid than the OD. Clear? Done? Now next. Now second in this example, if suppose CH3OH and CH3SH, which is a stronger acid, they will ask. This is a stronger acid. Why? Top to bottom bond length will be high, right? Top to bottom bond length will be high. Bond length will be high means hydrogen will be given very fastly. So hydrogen will be given very fastly by the sulfur. So this is a on the basis of bond strength. Next. Now third, on the basis of it's a what? Conjugate base. On the basis of conjugate base. Now on the conjugate base, how we can see the stability of which one? On the basis of conjugate base we can see the stability of which one? Alcohol, right? Now you see here H2O they have given and ROH they have given. Okay, H2O they have given, ROH they have given. Its conjugate base will be the OH minus. Now its conjugate base will be the RO minus. Done. Now R is a plus I group, right? Alkali. Now plus I groups will decreases the stability of carbanion. So here H2O is a more strong acid than the alcohol. More strong acid than the alcohol. Clear? This is very important. Very important. H2O is stronger acid than the what? Alkali alcohol. Clear? Now this is alkali alcohol. Done? Next. Now only the one point you remember. Acidic nature of alcohol, acidic nature of alcohol is dependent on the alkoxide ion stability. Alkoxide ion stability. If the alkoxide ion stability increases, acidic nature increases. This is what is the alkoxide ion? This is a OH, alcohol. By the removal of this H plus, it will form the alkoxide ion. This is alkoxide ion. This alkoxide ion stability, this one, its stability increases by minus I groups. Its stability decreases by plus I groups. by plus I groups. Clear? Now this is a very key point you have to remember. Very key point you have to remember. Done? Clear? Now here let's suppose, if suppose they have given the CH3OH, CH3OH, CH3 and CH3 COH, CH3 and CH3. If they ask which is a more strong acid or acidic nature order, so here the more the plus I groups, more lesser will be the acid, right? Clear? You can see this conjugate base will be the CH3O minus. Its conjugate base will be the CH3O minus and the H, and it is a CH3, and its conjugate base will be the CH3O minus CH3 and it is a CH3. Done? Clear? Is it clear? Now more the plus I groups, lesser will be the acidic nature, right? So acidic nature order will be 2 greater than 3 greater than 2 greater than 1 greater than 2 greater than 3. 1 greater than 2 greater than 3. Clear? Now here whenever this ROH they have given, stability you have to cross check on the basis of breaking of the which bond. Now you see, if ROH, this one, if you break this bond, if you break in the ROH, in the ROH case, if you are breaking the oxygen and the hydrogen bond, now this RO minus, this is a acidic nature, then you have to cross check the acidic nature. If you break the oxygen, this hydrogen bond, or this hydrogen if it is given to the solution RO minus, now then you have to cross check the which one, acidic nature. This acidic nature, which one, 1 degree alcohol is greater than 2 degree, greater than 3 degree. Clear? 1 degree alcohols are greater than 2 degree, greater than 3 degree. Here this alkali, if it is 1 degree, more acidic. Next to 2 degree followed by 3 degree. Next, if suppose ROH if they have, if you break this bond, how it will be dissociate? If you break this bond, R plus and OH minus, right? Then here you have to see the stability of carbocation. Now stability of the carbocation will be 3 degree, greater than 2 degree and the 1 degree. Okay? So whenever the alcohol they have given, now you have to cross check on the basis of which bond we are breaking. Done? Now next, let's suppose, if suppose they have given the question in this manner, this is OH. Done? This is OH. Let's suppose. Okay? Now this is a OH. Now here see, this is a carbon and this is a carbon. Now which is a more acidic nature in this compound they will ask. So this is 1, this is 2 and this is 3. 3 is more acidic than the 2 than the 1. Why? Because if this H is given to the solution, now here oxygen will get the negative charge. Then here this carbon is a Sp. Sp means more electronegative. Then here it is a Sp2. Then here it is a Sp3. Clear? Done? Now next. This is a OH. Now here it is a fluorine OH. Already I explained very clearly about this one. It's 2 and this is a 3. And here it is a NO2 and here it is a 4 OHCN. So what is the acidic nature of this question? You just comment in the comment section. I will cross check over there. Done? Clear? Now next, another question also it will give. This is the first question, and second question you have to try to from your own. The OH if they have given, and here it is a fluorine. And the second one, and here it is a fluorine. 1, this is 2. This is a fluorine. This is 3. And here it is a fluorine. Okay. Now this is 4. Now try this answer also. Okay, try this answer also from your end. Now we'll see the which one, acidic nature in the carboxylic acid. Now next fifth one we are going to see, that is acidic nature of which one, carboxylic acid. Clear? Now in this carboxylic acid, how the acidic nature will be decided, now we'll see. Clear? First point you have to remember, in the carboxylic acid, now acidic nature in the carboxylic acid, acidic nature depends on its carboxylate ion stability, carboxylate ion stability, or its conjugate base stability, Clear? Now here which groups will be increase the stability of the carboxylic acid and which groups will be decreases the stability of the carboxylic acid? Now you see, this is a carboxylic acid. Let's suppose one acetic acid I will take, one formic acid I will take, one acetic acid and one formic acid. Clear? Now what I said, which one will be the conjugate base? Now for the acid, hydrogen should be given and it's a conjugate base, and this is a conjugate base. Now this conjugate base should be stabilized. Clear? Now here also hydrogen should be given and its a conjugate base should be stabilized. Done. Now these two are the conjugate bases. Of the which one, carboxylic acid. Now here you can see, this is a which group? This is plus I group, right? Now plus I groups, what it will do? It will decreases the conjugate base stability. Now here this is a normal hydrogen and this carbon bond length will be high. So compared to this one will be the more acidic, right? Because it will not increase any electron density of this carbon. Done? Clear? Means by this point what I can say, plus I groups decreases the stability, plus I groups decreases the stability of carboxylate ion, and minus I groups increases the stability of carboxylate ions. Clear? Now this is a one key point you have to remember. Now we'll see first question. Now we'll see first one. Just now we have seen which one is a more acidic in the formic acid and acetic acid. If you take, which one is a more acidic? Formic acid is a more acidic than the acetic acid. Clear? Now second one. Now what I said, now if the plus I groups are increased, acidic nature of the carboxylic acid will be decreases, right? Now this is 1, now this is 2 and this is 3. Clear? Now the order will be 1 greater than 2 greater than 3. If the plus I group, this is CH3, don't get confused. This is CH3, this is CH2 and this is a C, here C and this is C. Clear? Done? Plus I groups increases, acidic nature of the carboxylic acid decreases. Now let's see, if suppose if they have given in this manner. No, if they have given in this manner, now which is a more acidic? Now here the order will be 3 greater than 2 greater than 1. Why? This is sp carbon, this is sp2 carbon, now this is sp3 carbon. Already I explained very clearly, percentage S character increases, electronegativity increases, conjugate base stability increases and acidic nature increases. That's it. Done. Next. Now next one. Now next one, here CH2 COOH F. Done. Now here the CH2 Cl and COOH. Clear. Next CH2 COOH Br. Then next one will be the CH2 COOH. Which one? It will be the somewhat CH3 will take. Now here which one will be the more acidic? The minus I groups are nearer to the carboxylic acid, that will be the more acidic, right? So 1, 2, 3, 4. So 1 greater than, 2 greater than, 3 greater than 4, because this is a plus I group. This is a plus I group. Done. Now next, if suppose they have given in this manner, double bond is here. Here. Now here the next, if suppose double bond is here, no, here the double bond is here and here it is a F. Now here it is a double bond. Clear. Here it is a NO2. Now among the 1, 2, 3, which is a more acidic? Which is a more acidic for the carboxylic acid? You just comment in the comment section. I will check it in the comment section. Clear. Now next another question also I will give you. CH2 COOH. This is NO2. Clear. Now this is a CH2 COOH CN. Clear. Now CH2 COOH, which one? F. 1, 2, 3. Among this 1, 2, 3, which is a more acidic? That you just comment in the comment section. Clear. Now next we are going to see the which one? Basic nature of amines. Next one we are going to see the which one? Basic nature of amines. So how to identify the basic nature of the amines? To identify the basic nature of the amines, the first key point you have to remember that now if nitrogen lone pair, if it donate very fastly, if it is donate very fastly, nitrogen lone pair, if it is donate very fastly, its conjugate acid should be stabilized. What? It should be stabilized. Sir, what sir? I did not understand. Now listen. Here this is a CH3 NH2 they have given. Done. Clear. Next this is a CH3. Now this is a N and its lone pair of electron, and it is a H and it is a CH3. If this nitrogen lone pair of electron, if it is given to any electron deficient species, then nitrogen will get the which charge? CH3. Here the nitrogen will get the positive charge. Done. When this nitrogen got the positive charge, this is a conjugate acid, right? This is a base and it's a what? It has given its electron pair to the which one? H plus. Now it has accepted that H plus. Now it has become this conjugate acid. Now this conjugate acid will be stabilized. This positive charge will be stabilized by the which groups? Plus I groups, right? Plus I groups. More the plus I groups, more will be the stability of conjugate acid. Done. Now here also, here CH3, here N, here the H, here the positive charge, here the CH3, here the CH3. So what is the key point you have to remember? What is the key point you have to remember? Now plus I groups increases the conjugate acid stability. Plus I groups increases the conjugate acid stability. Minus I groups decreases the stability of conjugate acid. The conjugate acid stability. Plus I groups increases the stability of conjugate acid, minus I groups decreases the stability of conjugate acid. So here also sometimes they will ask you. Now Kb and pKb, Kb and the pKb, clear? Now Kb is inversely proportional to the pKb. Kb if they ask means, Kb if they ask means more basic among them they are asking, which is the more basic them they are asking. Now if they ask the pKb means less basic among them they are asking. Okay, you have to be very careful with these points, clear? Sometimes they will ask you lower to higher or higher to lower, higher to lower. Done. Now we'll see the some questions based on this concept. First one, here the CH3 NH2 they have given and normal ammonia they have given. Which is a more basic, clear? Now you see this nitrogen lone pair of electron if they have given, this is, it will become NH2. Now if this nitrogen lone pair of they have given, it will become NH3, clear? It will become NH3 plus. Done. Here this is a conjugate acid, but this conjugate acid is stabilizing by the plus I group, right? Plus I group. Done. This is a more basic, done. More the plus I group, more will be the basic, If suppose if they have given ethylamine and methylamine they have given, ethylamine and methylamine and ammonia they have given, which is a more basic? 1, 2, 3. So 1 greater than, 2 greater than 3, right? More the plus I, more will be the basic, clear? Now let's suppose, if they have given this is a NH2, now this is a NH2, now this will be the NH2, which is a more basic if they ask, already I explained you. Now carbocation stability and the basic nature of the amines with the inductive effect stability will be same. See here this nitrogen lone pair of electron if it is given, here what it will get? Nitrogen charge, positive charge. Here this carbon is sp3. Now here nitrogen will get the positive charge and this carbon is sp2. Now here the triple bond and nitrogen will get the positive charge and this is a sp, this is sp, right? Clear? Now more the acidic nature, more the what? More the percentage S character, more will be the electronegativity, right? More the electronegativity, lesser will be the basic strength. So here the key point you have to remember, percentage S character increases, basic nature decreases. Percentage S character increases, what? Basic nature decreases. So answer will be 3 greater than, 2 greater than 1. This is 3, this is 2 and this is 1. Clear? Done? Now next let's suppose. Now let's suppose if they have given here the fluorine NH2, now second NH2 chlorine, now third NH2 bromine. Among the 1, 2, 3, which is a more basic, you just comment in the comment section. Clear? Now next amines. Now in the solvent, this is, there is no any explanation for this one. Actually this explanation I will give you more clearly when the chapter called the amines start. Now as of now you just remember, if the polar protic solvent they have given, polar protic solvent they have given, so 2 degree amines are greater than 1 degree amine and this is a 3 degree. Clear? And aprotic solvent if they have given, now 3 degree amines are greater than 2 degree amines and this is 1 degree amine. Sir, why it is giving very clearly I will explain when the chapter is called amine start. There I can explain very clearly, there you will understand very clearly. Okay? Now done. Now next we are going to see the dipole moment. Now what is the meaning of the dipole moment? Now dipole moment formula is mu is equal to charge into distance, right? Charge into distance. Clear? Now here, if one point you have to remember for the dipole moment, if hybridized orbitals, on central atom without lone pair on central atom, hybridized orbital on hybridization, or else you can say take it as on hybridization on central atom without lone pair, those compounds dipole moment is zero. Sir, what is this point? We did not understand, sir. Now I will explain. Listen carefully. So here, if you take the which one best example for you, I was going, that is BeCl2. What is the hybridization of the BeCl2? Beryllium contain 2 valency electron, 2 chlorine, this is S and P. So this is hybridized orbital, hybridization is sp without lone pair, so its dipole moment is 0. Mu is equal to 0. If you take the BF3 hybridization is sp2, so its dipole moment is 0. Clear? Comes to the CH4 also dipole moment 0. If you take the PCl5, dipole moment 0. Done. If you take the SF6, dipole moment 0. If you take the IF7, dipole moment 0. Clear? Done. Now here, in which case the dipole moment will be considered? H2O and NH3. These are lone pair containing species, right? So for this one, dipole moment will be not equal to 0. For this one also, dipole moment will be not equal to 0. But H2O is having the higher dipole moment. In the NH3, when it compared to the NF3, NH3 is having the higher dipole moment than the which one? NF3. Why? Because here nitrogen, this lone pair of electrons, and this is the hydrogens. Now here the fluorine, right? This is fluorine. Here it is a fluorine. Now here the dipole moment vector will be in this manner for the fluorine case. Now here the dipole moment vector will be towards the nitrogen and towards the lone pair. Clear? Now here the dipole moment vector will be high for the ammonia than the NF3. Clear? Now next one. Now which one is having the higher dipole moment? Here the CH3. Now CH2 and CH triple bond CH. Now which is having the higher dipole moment among these three? You just comment in the comment section. Clear? Now by this, application part of the total mesomeric effect has been completed. Now what is the mesomeric effect and where its application part it will be used in our which reactive intermediates and its alcohol or its acidic nature and its what basic nature and its dipole moment already we have studied very clearly. And if you want the class notes, I will give this class notes in the description. Okay, you can download that notes in the description also. Okay, now later next we will see with the which one, another lecture, that is mesomeric effect.